So today we're going over the rules of exponents and scientific notation. Many people ask what scientific notation is, and it's used in many fields of study. Um, the first thing into understanding exponents is that, as it says right here, an understanding of exponents is important in solving problems in algebra. In expression 5 to the power 2, the 2 is referred as an exponent and the 5 is referred as the base. So the exponent, as I describe, 5 to the power 2, the 2 is the exponent. So that basically means that you times 5 by itself twice. And another way you can say it is that either 5 to the second power or 5 squared, or it doesn't really matter how it's said. So for example, if you see 5 squared, then when you do the problem, it's going to be 5 times 5, which equals 25. Another thing is that there's 5 to the third, or 5 cubed, which means 5 times itself 3 times. 3 times. So basically, if you see 5 to the third, or whatever number the exponent is, it just means that you have to times the number by itself in order to get your answer. So basically this is how they explain it, is that the number b, for example b to the nth power, which means b times itself how much ever times you do it. So we're going to move on to example 1, evaluating the power of a number. So A, it says to evaluate 5 to the power of 2, and we basically just went over that. It's just 5 times itself twice. So let's move on to B. So negative 3 to the power of 2. So don't let this negative, even though the base number is a negative, don't let it confuse you, because it's not that difficult. It just means that you have to do negative 3 times itself twice. So as you can see, negative 3 times negative 3 is 9. It's just basic algebra from there. And so let's move on to C. N to the 4th power means to times 3 by itself 4 times, which equals 81. D, 1 to the 1000th power. So you might think that in multiplication, 1 times 1 equals 1. So no matter what you put, no matter what power 1 is to, it's always going to equal 1, as you can see in D. Because any number multiplied by 1 or any number, the number 1 multiplied by itself, any number times equals 1. And just like how they did it the reverse, 1000 to the 1st power is any number with the exponent of 1 equals the number itself. Okay, let's move on. Example 2. So we're going over the importance of parentheses. Okay, let me get paper out real quick. Paper. Okay. Alright. Okay. So example 2 is importance of parentheses. So A says to evaluate. It says to evaluate 2 to the 4th. So basically, I'm gonna write it just like that. So let's go to, that's a 2, sorry. 2, 2, and 2. Okay. So basically, you're going to work step by step. So, let's go. Negative 2 times negative 2 is 4. So, you rewrite it. Just rewrite it every step. And it is important to write down your steps because certain people or teachers like to mark you down for it. So it's important to show your steps and show that you understand it, that you understand the context. So to continue this, 4 times negative 2 is 8. Then 8 times negative 2 is 16, and that's your final answer. So the importance of the parentheses is just to work step by step. So even if it says negative 2 or 4 without the parentheses, it just basically means the opposite of 2, 4, or negative 1. Okay, so that's basically it. That's probably the important part of this part. We're gonna move on to the rules of exponents. So the rules of exponents, basically, you have to consider that, say you have something that says times 2 to the third. Okay, so you know that 2 to the second power is 2 times itself twice. So you're going to write that down. You're going to multiply it by 2 to the third power. So it's going to be times, you're just going to write it 2 more times. Then to equal it, you don't, most times you won't have to give out the exact answer, but some problems actually just want you to, or no, that's the wrong answer, 2 to the 5th power. Some answers just want you to write it in exponent form. So another important, this is called the product rule. The product rule for exponents. Now we're going to move on to the quotient rule for exponents. Quotient rule for exponents. Okay. So basically you set it up as a to the m power, a to the n power equals. So basically the quotient rule of exponents just basically means that when you see a to the m power over a to the n power, it just means a to the m power minus n. And yeah, so one example would be 2 to the 5th power over 2 to the 2nd power, which equals, it just means 2 to the 5th minus 2 to the 2nd, or minus to the 2nd power, which equals 2 to the 3rd. It's not that difficult. Okay, so I think one more important rule is that we're gonna go over the zero exponent rule. So the zero exponent rule basically says that anything to the 0 power is gonna equal 1. So for example, 2 to the 0 basically equals 1. Basically, it's self-explanatory. So same thing as negative 2 to the 0 equals 1. 1000 to the 0 equals 1. 1 million to the 0 equals 1. Everything to the 0 power equals 1. And it's just, I don't know why it's like that, but it's just going to be like that because that's what it says in the book. But basically it's so self-explanatory. Another one we're going to go over is, this is probably the last, wait, let's see. Is this the last rule? There's the power rules. Okay. So the power rule is that, or the negative exponent rule, basically is set up like this. So a to the n power. If you see something like this, basically it means you're going to put 1 over a over m. So it, for example, if you do 2 to the negative 4, it's going to equal 1 to the 2 over 4, which equals 1 over 16. And that would be your answer. So it's that easy. Now we're going to go over the power rule of exponents. The power rule of exponents just basically separates them two. It goes, you're going to put parentheses and it's set up like this. And basically that means that when it's set up like that, you're going to multiply the power. So, for example, 5/4 over 3. This basically means that you're going to do equals 4 multiplied by 3, which equals 12. So it's going to equal to 5 to the 12th power. And basically that's it for the rules of exponents. I'm gonna go over one rule for the scientific notation. Scientific notation is real easy. It basically tells you how much zeros comes after a number. So basically it applies for very large numbers or very small numbers. So for example, the distance from Earth from the sun is about 93 million miles. So if they were asking for the scientific notation form, you would do 93 million. Sorry, I set that up wrong. 93 million equals 9.3 times, you can use your calculator for that, but basically scientific notations tells you that instead of putting all these zeros, you can just put it into an exponent form. So it would actually be 9.3 times 10 to the 7th power, because you go 1, 2, 3, 4, 5, 6, 7. And even though the decimal is right here, you'd still put 10 to the 7th. Does that make sense? And it can go the exact same way for a small number. Say this is a real small number. 36. So I think this is 6 to the millionth. I don't know what that's even called. It's so small. But that basically equals 6.0 times 0.000001. And if it's, let's say if you're going right, if you're moving the decimal right, it's going to end up being positive. The exponent's going to be equal positive. If you're going left, it's gonna be negative. The exponent's going to be negative, like this. That's going to be negative. So this one is going to be 6.0 times 1, 2, 3, 4, 5, 6, 7. So 10 to the negative 7th power. You see where I went there? So when you write it like this is writing it in scientific notation. This is how you write scientific notation. Sorry. When you write it like this, that's scientific notation. So more examples of scientific notation is 3.7 times 10 to the third, 2.5 times 10 to the negative third, 5.6 times 10 to the 8th, and even 1.0 times 10 to the negative 5th. So that's basically most of it, but we also have to go over how to move from a scientific notation to decimal form. So from scientific notation to decimal form, let's just say we're doing 1.4 times 10 to the 8th power. You're going to do 1.4, and you're going to go 1, 2, 3, 4, 5, 6, 7, 8. And you're going to fill in the zeros. So your answer for that should be 140 million. Basically, it's real easy. You can do this stuff in middle school. It's so easy. Let's do one more and then we'll wrap it up. Let's do 1.35 times 10 to the negative third. So it goes the exact same. Since it's a negative exponent, you're gonna do 1.35. Wait, let's mark this. Sorry. 1.35. Let's write it down here. I need more room. 1.35. And you're gonna go move it back 3 times. 1, 2, 3. Fill in the zeros. So the answer would be 0.00135 is your final answer. So I hope you enjoyed it. It's a real short video about something really easy once you get to know it, and yeah, have a great day. God bless. I hope you enjoyed this video. If not, then I'm sure there's more people teaching about this stuff, but yeah, have a great day. God bless, and I'll see you guys later. Peace.